Hi, Karen.
Hello.
Cheers.
Hi.
Nice.
Hello.
Hello.
Hi, Pascal. Hi. Hi, Michael.
Hi.
Hi, Martin.
Hi,
Hi.
Martin.
So we may want to do the agenda items the other way around because
Yes, we can definitely. It's just wait, is anybody else coming? Is pull request stuck? Yeah, comments. Squash. Okay, do housekeeping. No.
Hi, everyone.
exactly.
Looks as if we are complete.
Okay.
Okay, let's get started. So
So
hi everyone. Let me remind everyone that by being here, we all agree to the GraphQL Spec membership agreement and the GraphQL Foundation Code of Conduct. Let's start with a quick round of introduction in the order of the agenda. I'm Michael. I'm the host today.
hi, I'm Pascal. Also from Telegram.
I'm Sergey from Wondergraph.
David from Monograph.
Martin from Apollo.
Kamil from the Guild.
Awesome. We have two items on the agenda we want to discuss today. That is nested lookups and keys. And Pascal has miscellaneous spec things. If anybody else has something else that you want to discuss, we can put it also on the agenda.
Yeah, so this can go very quick, at least the first agenda item. The other one will probably lead to quite some discussion. So let me first enable the please do not disturb me mode, and then share the screen. Okay, so first the miscellaneous stuff. We have a few things. So Glenn has spent a lot of time implementing what we have defined, found a ton of bugs. I actually plan to spend most of today reviewing all the issues and going through and cleaning everything up. But you know how life is. I did do 0 for it. So I hope that I can do tomorrow more spec-based stuff. But a few questions have already been asked on there, which I'm not sure. So at the moment we have when we look at the union merging. So what first of all, the union merging is wrong at the moment, which is fine. Merge union, yeah, because it doesn't merge by intersection. I believe it currently merges by union. So this is something that we need to change in the algorithm anyway. But on the other hand, in the current algorithm, there's no way that union can be empty, right? In, for example, interfaces or enums, we have the enums is also wrong, but we have the interfaces, then it can be that an interface is empty. And there's a post-merge validation rule that says empty object type. We already discovered that we probably also need to have an empty interface type. Now the question is, should we add the same for empty union type and empty interface type? So it's essentially just the reason why we do it in post-merge is Azure schema is validating everything that can be done on a single schema. Pre-merge validation is more or less everything that has to be done so that we can merge. Then we merge, and after the merge, we do the checks and see if the schema is still valid. And what can happen is that an enum is empty, a union is empty, an interface is empty. Essentially, all the types can be empty.
Because of inaccessible and internal.
Or because of intersection. If there's
Yeah,
no,
or because of
there's no intersection,
yes. Yeah.
then nothing will be there in the end. So that's something that we have to add. Anyway, the rules there are quite simple. We could, I had a long discussion with this with Glenn. A lot of the post-merge validation rule we theoretically could do in pre-merge validation. But my personal opinion is that we should focus on in pre-merge validation just from a spec perspective. It doesn't need to be implemented this way by the implementations. But from a spec perspective, pre-merge is just to make sure we can merge, and then we do in post-merge everything else which needs all of the schema context. So we already, the is exposed thing, or is in composed schema, is in merge schema, these methods are no longer needed when we do it in the post-merged state, because we already know that nothing is there. Yeah, we have to go through all of the validation rules because as we were talking about and reshaping the spec, most of them at the moment
Yeah, just as a hint, we had this helper methods originally in the algorithms. Just as a refresher, is exposed, which is basically was a helper method which told you if basically a type system member will be exposed in the composite schema in the client facing schema. But if we do it post merge, we just inspect the type and it will be empty. And
I mean, in most cases, in query, we can just inspect the type, and if it's empty in the composite schema, in the composed schema, then it's invalid. Same for interface union and so on. There's a few places where this is used where we have to be a bit more creative. For example, implemented by inaccessible, which is a terrible name because it actually means something completely different. But here we cannot just rely on the on the composed schema, on the merge schema. We also need the context of the source schemas. And we said in the post-merge validation phase, we have the context of all source schemas and we have the context of the merge schema. So this rule is actually, I've created an issue for it. This rule is currently wrong because we still take the assumption that there's an annotated execution schema, which we ditched in the spec. So, but generally speaking, should we add specific rules for all of the types that can be empty? Is anyone against it?
No, it seems consistent with the other empty rules.
One question here. Empty interface, you mean interface without any fields or interface without any implementing types?
without any fields.
Without any fields, without any union members, without any enum members.
Which would basically be invalid GraphQL because GraphQL says there cannot be an interface or an object type that have no fields. And the same goes for a union. Without a single member, it would be invalid GraphQL. So we basically just ensure that the schema will be valid in the end.
Another question, like, do we consider at this stage type extensions? Because basically
it's all merged. It's more
Okay,
so what you get what after merge everything is completed. Like you have what comes out of merge is basically the composite schema. So the client facing API. That is what comes out of the merge algorithm.
but we Do we talking about like pre-merge stage? At pre-merge stage, we have only subgraph schemas. So I mean more like do we merge extension types within the subgraph schema?
Yes.
Because
I
basically,
yeah, and I think type extensions are mostly sort of a syntactic notion, like an STL notion. So when we talk about validation rules, we talk about the created schema, and that already has type extensions merged in.
Exactly.
Yeah, that happens.
Yep.
Even the type extension stuff happens on us even pre-merge validation. So in the source schema validation, type extensions are already merged together. We don't even specify this because that's just an assumption. Maybe we can have a note there that
Yeah, not would be good, just to clarify.
Yeah, and I think what the note would clarify is that we're talking about the schema as sort of a semantic notion, like similar, like the GraphQL spec itself doesn't mention behavior of type extensions either in validation rules, for example.
Exactly.
So that means, yeah,
it's also one of the big discussions we have in the course spec. If this should be at some point specified, but this is not something that we would specify.
Sorry, stupid, naive question. Tangentially related to this, if a type is not, lack of a better word, consumed, so not part of like an output in any way, does it even bother getting included in the composite schema?
Yes.
It's
just for schema evolution. You maybe want to have already interfaces or whatever. We discussed with Meta about that. I think Matt of Meta brought this up at some point.
Yeah, they even want to change in the core specification that allows you to have interfaces without implementations, so that you can already start writing components for interfaces without implementations before you have actual implementations.
Does this also, is this for, imagine you have a root type that's returning an interface, or where the name type, the core type is an interface that has no implementations.
So there are issues with that, because you couldn't possibly return something.
At the moment, it's invalid graph code. So forget about
there is a discussion around
that. It's
that.
just another example for the use case. You want to have the ability to expose an object type that is not referenced somewhere in the schema, so that you can write UI for this object type. So that's the main reason. If you want to hide something, you have to make it inaccessible.
Okay.
Or you can also do what we do in Fusion, for example, is we have but that's not specified in the spec. We have a pre-merge, also source schema annotations where we can say we don't want this type and then we remove it. But that's more depending on the composition tooling that you use.
Yeah, don't intend to derail the discussion here, so we can always talk about this another time.
Okay. Yeah, so first one is we add the rules. That means we have an empty merged union, empty merged interface, empty merged input, I believe we have already, and an empty merged enum type rule. These are very easy to do. I can add them. Then next thing is, let's add an action for this. Then add the rules. Then next thing is the empty merged object type. So let's have a look at the rule. Let types be the set of all object types in the composed schema, blah, blah, blah. Fields must not be empty. That's a problem, because we have no queries. So that would fire for both. So the question is, should we, in the empty merged object type, should we exclude root types? Because that's something that we anyway have to do. Because if you make all mutations inaccessible and all subscription inaccessible, I think the composition should still succeed without having to make the whole subscription type inaccessible. because that would mean that no one can add subscriptions in the future.
Yeah, it's basically a practical, a question about convenience. Like, do we force people to then make the root type inaccessible, or is basically do we remove the subscription type, a root type, if there is no subscription defined?
I would, so for mutations and subscriptions, I guess if they are empty, I would say it's fine, because like if you want to have, like if you compose mutations and subscriptions and you say, oh, I don't want to expose it yet, and I mark it inaccessible, then, you know, and if it ends up with like no mutation or no subscription, I think it's fine. With the query, it's a bit different, no? Because you have like this.
The query is required, so we cannot remove it.
Exactly. And then because of the lookups and all of that, it could potentially be empty. So, I mean, I'm in favor of having this as a rule, because then it's like, you know, it literally says you have to have queries. With empty object type, it says, oh, the query was empty, but, you know, now this specific.
Yeah, but what I meant is like the graphical core spec says there must be a query type.
Yeah.
I also think that we keep the no queries. That's fine. We just say in the empty merged object type, if it's a root type, ignore it. Do not run, essentially empty merged object type does not run for root types.
Yeah, we would remove the root type. This would allow you to, sorry, David, that would allow you to be more flexible in the schema evolution story. David?
What is the argument for not allowing empty subscriptions and mutations?
None.
Okay.
It's just something that could happen when you have a subscription type and you ignore the subscription because you don't want to have, you make it inaccessible because you don't want it for clients to be consumed. In that case, you would end up with an empty subscription type. And currently, this would lead to a composition error because you haven't made the subscription type inaccessible. And that's a problem because root types should not do this.
Oh, okay. So it's about explicitly marking it as inaccessible rather than letting it basically propagate as essentially inaccessible.
Yeah, because like the one, like with standard object types, what we discussed, it's unexpected if we just would remove them, right? It's rather we tell you, okay, this is now empty. Is that what you expected? If yes, mark the type inaccessible. But with a root type, if you have to mark them inaccessible, then it becomes a hurdle with multiple teams organizing to get now a subscription back in form. Right? That's why on the root type, it's a hindrance.
So you just brought something up that I don't know. Maybe I'll bring it up at the end, actually.
So okay. Just write it down because we're very good in overshooting the time. So
So one question, like, do we allow to have inaccessible fields of a subscription or mutation that ends up with an empty mutation or subscription object, or not really?
That's exactly what currently we do not allow.
Why?
Because we haven't specified it.
Yeah, but I mean, like, it's a valid case, no? To have like all the fields inaccessible, but then it ends up with, you know, it's not like it's empty, so we can literally just not put it in the, you know, public schema.
Exactly. And at the moment, the empty merged object type would, because the root type of queries and of subscriptions and mutations are object types. And currently, without ignoring them, this rule would lead to this error, but we don't want this error. For root types, we actually have to say, if it's empty, just throw it away. Just for the root types.
Perfect.
And then we have to specify here as well, because that's not complete. We have to say in merge that we actually want. So now we merge all the types, which is great, but the schema is still empty. because we never say that we want to create a schema based on the query, the type, and so on. So that's another action.
One small question. Why we don't want to allow empty query types?
Because it's
It's
invalid
not
GraphQL.
allowed. The
There's-
GraphQL core spec says that you have to have a query type, and this query type has to at least have one field. That's
But it
GraphQL core spec.
Actually, always have at least 3 fields. No,
What?
No, these does
actually, always have at least 3 fields. It has a type name. It has
This is
introspection.
not, no, these are not fields. Like the GraphQL spec specifically defines that these are execution features where you can, technically from the user's perspective, you can look at them as fields, but they are not fields. They're also not in the schema.
Yeah.
That
And
is
that's-
also core spec.
Yeah, the core spec disallows it, so we have to make this validation rule.
Okay.
Then this one's clear. Now we have this one. Only inaccessible children, which is a rule from which we have from Federation. Why can I not search? Only because I did a typo. Inaccessible children. And this rule at the moment overlaps completely with the merged. Am I blind? Only inaccessible children. There we go. So essentially what this does, because this is a post-merge validation rule, only inaccessible children would be equivalent to this empty merged input, empty merged interface, empty merged object. Because if all the fields are inaccessible, then they are not merged. So the question is there any reason why this is a specific rule in the composite schema spec? Or should we remove it?
And when you say
I'm not
you mean
sure.
in favor for the sorry.
Oh, I mean, I just wanted to say I'm not sure. We could ask Derek or Shane. Maybe they have some more insight into sort of the current behavior in Federation. It definitely seems like they overlap, and we only need the empty object one. But I might be missing something.
That's good. I will open an issue, then we can discuss this. And if it's just, it's the same thing with that we have with external and so on, which we have to discuss.
But
Then
in Federation, there is no empty object type error. It's like only inaccessible children, and empty merge type is only for inputs and enums in unions, I believe, or enums. Yeah, enum and
so that's the reason then we have the inaccessible one.
yeah, because the only reason to have an empty object type is inaccessible. For the rest, it's the intersection, right? So there's just different logic. So with empty object, we will because with the error message, we need to say why it's empty, right?
yeah. And
So,
here we can actually say that it's empty because now in the composite schema, we have 2 reasons why it can be empty. It can be internal, or it can be inaccessible.
yeah, the latter is much more difficult to write, but yeah.
In current Federation, is like if all fields are external, is a different error message.
Yeah, it's also like all the errors in the Federation are like reason based, I would say.
Yeah.
So,
But if you had a combination of inaccessible internal and external fields, giving the reason why it's empty might be get tricky. If everything's inaccessible, then you have if you were to keep this only inaccessible children, but it could be a amalgamation of different reasons why the end type is empty, right?
Yeah, but that's fine because if you have a field which is external, it's in the composed schema, right?
because it's defined in another subgraph.
Yes, so the type is not empty. This really only is triggered if the type is completely empty. If this is the case, if you look at the example, the case here would be we have one subgraph, one source schema. Well, that's a bit dumb, but we have, yeah, the examples here are not ideal. But essentially, merged would be we have two subgraphs. One adds name, the other one adds email, and then one hides the other. So it could be that we have type profile. In one subgraph, it's string. It's shareable, just to make it correct, in accessible, and we have email, which is also shareable. And in the other subgraph, we have the other way around. We have this, and now when you merge it, everything is inaccessible in the merged schema.
Yeah, yeah.
Yeah, so that makes sense. The question is just what do we do with internal? We can just say only inaccessible or internal.
Yeah.
And we remove the empty merged object then.
Yeah, or maybe some kind of generic term like only, I don't know, hidden children or something.
Unpropagated. I don't know. I know what you mean, though, Martin.
Only non-mergeable children. Yeah, we anyway have to refine the names because implemented by inaccessible, the name is, it makes sense to have the rule, but the name is just something because what it actually means is that you have not implemented the field. And the rules, the error is implemented by inaccessible. So it should be that the field is actually not implemented. But anyway.
And inaccessible children also is like politically, So I'm fine with like changing it. Like today I saw like in documentation somebody mentioned like allow list, formerly known as whitelist, which is like
Yeah, we made that same decision a while back.
Yeah.
Okay, good. So last one, I believe we should wait for when Derek is in the call because he has opened the issue, so he probably also has something to say about it. Essentially, you can read it. The question here is referencing fields with required that specify arguments. This should probably be a validation rule.
I have that on my to-do list, Pascal. There's 3, we discussed it with Derek.
Okay.
There are 3 validation rules that we have to write.
Okay, can you open issues for them so that we have them on?
Yeah, I have them on my note, but I put them in the issues. Yeah.
Then either fax me your note sheet or open issues.
I'll send it. I'll send it over. I already discussed it with Glenn a bit, but yeah.
All right, well, okay. So that's for now. I will do this now every week because the more we write spec rules, the more it gets obsolete already. So I will spend more time in cleaning up what we have, and then I will run into many issues. You can take any of these rules at the moment, and you find stuff that needs to be added or needs to be changed from discussions of the previous few months. So that's what I'm going to do. Okay.
Yeah, this is, by the way, like we write, Pascal and me, most of the spec text at the moment, and then Glenn is trying to reason them out, and that's how we weed out a lot of these inconsistencies. Because when you write them, often you either forget things or you forgot about some older rule that you have there.
So the intention that we have is that the one which writes the spec should write the implementation.
Yeah.
Because that's the way you can actually validate that the spec is good enough.
Yeah.
And then once other people implement it, then there will be changes again, I guess. Okay, first topic done. Now, second topic. Let's talk about keys.
That's a bit contentious, but
Yeah, that's going to be a hot topic. I hope 30 minutes is enough. So I had a few questions about keys, and one of the main questions I had about keys was about the implicitly shareable part. And I wouldn't consider a key field or a field which is in a key shareable anymore. Because it isn't. It's only shareable in the context of the current subgraph. So if two queries, two subgraphs define the same key, everything is fine. But as soon as one subgraph doesn't define it, let's say we have this, then it's a composition error. Because this field would have to be shareable. So it's the terminology to say that a field which is in the key is shareable is misleading because it isn't. It's only not validated or in the context of this subgraph. Yes, David?
But I think it's clear it's if a field is referenced in the field set of a key, in that specific case, it's implicitly shareable. No other case. It has to be referenced explicitly in the field set of a key directive.
Yes, but only on this subgraph. If another subgraph...
Correct. Only in this subgraph.
So the evolution would be that if I want to make slug a key, is essentially I have to say that slug is a key, then make this shareable, so that I can actually have I could directly add another subgraph to it. You're right. But I need to make it here shareable so that I can have a lookup for slug here. And that's a bit weird.
Correct. Yeah, if you want to introduce a new sorry, Camille. If you want to introduce a new target, you can't and it's non-shareable in another graph. You won't be able to do it because of the rules surrounding shareable, correct?
Yeah. Camille?
Obviously, I'm muted. What I wanted to say is that like the key is a contract, right? Hey, I want to use it. Everyone else could also use it. So then whatever. And so like I would really treat them as shareable by default. Like first from the ease of use, pretty much. Like you have a key and then you have to define that it's a shareable, which is like double work. And most of the time, like the recommended way, I guess, would be to have the like ID field always shareable. I mean, as a key, you know, that would be, so imagine now adding the shareable to every single time because, yeah, I want to share it. And also just by the definition, right? Like I accept a key of the field, you know, ID. So it has to come from somewhere, right? So it's already somewhere else, right? Which only proves my point that it's like
That's
it has to be shareable, right?
The thing I see a problem is more that I cannot add post by slug to this subgraph without changing this subgraph. Just because of the key.
okay.
I need
Yeah,
to
I think that the reason this seems confusing is because of the wording. When we say that a field mentioned in a key makes that field inaccessible, we don't mean that it becomes inaccessible in the composed schema. What we mean is that it gets sort of implicitly marked inaccessible in that subgraph, similar to you marking it as inaccessible.
Right?
Sorry?
Shareable, right? Not
Oh, sorry. I'm
okay.
confusing things even further. Shareable.
I'm confused.
The contract with shareable is still like the same whether you explicitly mark it shareable or whether it's implicitly marked shareable because it's used in a key. It still needs to be consistent between the subgraphs.
But shareable is global and the key is local, right?
No, but shareable isn't global. Like the
Everybody has to mark it also.
Yeah, you need to mark it shareable in all
Okay.
subgraphs.
I see. That was my bad. I thought it behaves like inaccessible, that you mark it on one subgraph as shareable and it becomes shareable on all subgraphs.
No, it's specifically that each team recognizes, okay, this is now shared across teams, and I have to be careful with semantics here.
Makes sense.
Because otherwise it could, like ID could be accidentally shared on subgraphs and could mean different things for different teams. And the moment you put shareable on it is basically, okay, we have to talk. This is this.
Okay, makes sense. David?
Yeah, so I just kind of wanted to reiterate on this is that the whole kind of reason shareable exists is it's for an organizational problem rather than a schema problem. You have a graph that owns like I'm using the word owned by someone implements a graph with a field on a type. They are the original implementation of that type, so they have responsibility for it. They basically dictate whether that field should be allowed to be resolved in other places, and then if it is, it needs to be resolved exactly the same. So once you relinquish that kind of responsibility with shareable, it essentially means anyone else can come along in another graph, and as long as it's shareable in that graph, stick it in there and whatever. And if you imagine you have a field with like a common name like ID or name or whatever, and someone unknowingly in a different team tries to add name or ID with a different intention, oh, it's already a field in this graph, then those teams talk and make sure that it's actually doing the same job or whether that field should be renamed to something else.
Yeah.
Now, back to this about keys, is that essentially in the contract you had before, if you wouldn't mind, would you remove key ID from the left-hand graph? So for this to have ever composed, it means that post ID, this graph here is the only graph that has ID in any of the graphs. Otherwise, it wouldn't have composed in the first place. So if you want to then add a key in the right-hand graph with key ID, you would still need to like. There's no way around it. Where you would still need to talk with the other team to say, look, we want to make this a key. We know that you already have a field called ID. We want to use that as a key. It's still there has to be a conversation there. There's no way around it, because it wasn't a key originally in their graph, and it was nowhere else defined. So by putting it as a key, and I understand it's an extra step with you can't just stick post by slug up in there in the lookup, but this conversation has to happen for the reasons I mentioned.
So you say that when you do a lookup based on something else, this conversation has to happen between the two teams. I mean, with keys,
because because the first graph, it's just a normal field. There's nothing about it being a key. It's just ID on post. It's the only graph in the whole composite schema that has like.
I mean, the key is a bit of a special case because we have the key lookup in both cases, right? So let's talk about post by slug, because that's basically just, this is like the inventory, the post service, whatever. It defines a slug, and I want to extend based on slug, right?
Oh, sorry. When I was talking, I was assuming that we were adding post by ID, but sorry, yeah, post by slug. So imagine it wasn't shareable. Slug was not shareable in the left-hand side.
Yeah.
It must be shareable, right?
In this
You
case,
have it on both graphs, so it must be shareable on both.
Because it's in both graphs, right?
Yeah.
The point I'm trying to make is if it were not shareable in the left-hand graph, so slug was not shareable there. To ever have composed this composite schema, it must be the only instance of that field. Otherwise, it wouldn't have composed because
Yeah, that's all clear. I mean, in the question in the so my assumption was wrong that Cherub was global. So that's one thing which fueled the confusion. But the question is, why do we have to define the slug on this subgraph even? So why do we force people to expose the field, even though the only reason why this has to be exposed is because of the key?
I'm not sure I follow here.
So basically, this is a good example. So you have post by ID, you have post by slug, right?
Yeah.
And theoretically, it would be enough for the composite schema to return this. Because we don't need ID and slug, neither in execution nor in definition. We have the types here.
So now we're talking about the semantics of lookup.
I mean, the semantic of lookup are the same, right? So the question is,
well, but it needs to match, like, for instance, at the subgraph level, we want to be able to validate that the slug field has the same type, both in the input argument and in the returned field.
yes. But
so I agree that strictly taken, we don't necessarily need to be able to return those fields. Like the second post definition could be valid, but then I would say we need to define ID and slug as external for similar reasons that we have for require, for instance.
Where it becomes very complicated with the key is actually when you start with nested lookups.
so
I think that's the origin where this discussion stems from, right? It's not.
this now becomes a problem when we have nested lookups, because let's just
There is a solution for that, but it's kind of looks very dirty.
Before we go there, I just want to make one point here. If you just look at this would be perfectly executable and composable, theoretically. Because
depending on how we define the validation rules for lookup.
Yes. And
Yes.
also the requirements for what a key is and how a key works and so on. But from an execution perspective, from a user perspective, I have a slug here on post, and I have a post by slug here. We know that this is the field name, otherwise you have to override it. You could also say that this is what was the syntax here? Something different, or do we just say foo? And then you know that there must be a subgraph which defines foo, as a field on post, because implicitly this essentially is this. And we know that we have the type information, and we have the field information implicitly here with slug. So just from an execution perspective and from a composition perspective, theoretically, this is enough so that we can compose and we can validate. We do the double bookkeeping here, and this becomes a problem when, let's move this up again, when we talk about nested lookups. Because I would say exposing the ID here and the slug here is fine because we have the data. But even if we have two lookups on the same type, we already have the issue that these have to come from the same data source on the subgraph, and this is already a restriction.
Or you would need to put external on it, right?
Yes, but then you also need provides. If they're not in the same data source, you would have to say that this is external.
Yeah, it becomes more complex.
And you would have to say that this
depending on the path that you now get the data from. Yeah.
And then you would say that this provides the ID, and this provides. This could
Or it
also
doesn't.
be implicit.
Or it doesn't.
Or we can sort of define that as part of lookup semantics.
Yeah. I know, Kamal, your argument is that both of them have to have both information. So when you go by ID, you also need to have the slug, but when you go by slug, you also have to have the ID. But the problem here is that you basically, with this specification, you force it to be the same data source.
Yeah, you could have like there are a lot of examples where this is not the case, where you have optimized reads. I wouldn't force people to have this, and I think it's acceptable to, depending on which way we decide, there are the acceptable solutions for this. For instance, external could be one of them.
Yeah.
We just have to decide and find out what works best.
And I would definitely still say that the common situation is that an object can be looked up and
Yes.
by both keys. So
Yes.
it's fine. It's fine if you have to do a little bit extra work in case that isn't.
Yes, it's more looking now like also the nested case that we look at. These are edge cases, right?
Yeah.
Just these things should work also with edge. We should have a view on these edge cases.
It's about prohibiting implementation and way of implementation by specification, because you wouldn't be able to have two blob storage, and one blob storage just has the by ID lookup and the other blob storage has the slug lookup.
Yeah, we should avoid ambiguity like in these cases. Just to
now this problem gets super annoying when we talk about nested keys, because there's the block post by ID, and on the block I can do post by ID. We've talked about nested lookups before. It could be that this might be one example that you have, but it could also
and nested here in the we discussed in the beginning when we started this the GitHub case, right? Not nested like we just have a technical type where we hide internal lookups behind, but nested in the case I have to combine keys now.
Yeah, and another example which is very, very common, if you have tenants or workspaces and they can have different users, then you probably don't want to have user by ID on the root, or you can, but maybe you do not want to, and then you have these combined keys. Now, this is a bit of a problem in case of what do we do here? Because when we want to define the key, essentially the key of post on this subgraph is block by ID and post by ID. Because we go through block by ID, through post by ID, we get the post. So that's
there is this is one thing, and we talked already a bit about that, but it becomes complex because like you might have multiple ways to get to block, so you have an explosion of keys, kind of.
Well, I mean, I would say in cases like this where sort of the post ID is relative to a blog, there needs to be a blog ID field in the post type.
Yeah, but then we force the user to actually do this.
Well, yeah, either that or plain blog ID field.
But the block ID field wouldn't be enough, because you need to have the identity, because this is ID, but this is ID on block.
Yeah.
So not say blog ID, because you need to have the identity. So we force it into this. We force this field. We force this reference in the result.
All we would need is like in the original proposal we also had is, if you remember, on the fields, you need to give the ID that you have flattened on the object to give it semantics, that this field is actually semantically equal to block.id, kind of. But you can already see this while this is not, I don't expect this to be the main case, but if we support it, we should have it like cleaned out. This is
And the argument again is that we now force the user to into a specific structure, you know, by having this field here.
Yeah. Yeah, I mean, I think having a blog ID is requirement that's sort of forced on the user by the domain model, because we're saying a post ID is relative to a blog. But I agree that sort of the full reference to a blog type, that's overkill. So maybe we do want another solution, as Michael mentioned, for sort of establishing semantic equivalence between a blog ID and the ID field of a blog, so people can avoid having to like expose the reference to a blog.
Yeah,
This could help also in other cases, I think, efficiency-wise, right? Where you can kind of flatten things out and say, but actually this is there, and then you make it inaccessible or something. It's like technical fields that, or even internal, that you don't expose to the public schema, but that you have there for the gateway to plan. I don't know.
Kamil?
I just wanted to say, probably know my opinion. It's it feels wrong, you know what I mean? Like it's too complex.
Yes,
It's just like I don't have other solution, but this one seems very like complicated and like cumbersome. Like, you know, you have to specify the block and the ID, and like, you know, it's
I mean,
it's
there
not
is-
like coming from like Apollo Federation perspective, when you think, oh, there's a key, so I need to fulfill the key to resolve the entity. It's, I guess it's okay, but then it means that, I don't know, it's just like, you know, with the block ID, additional fields to reference, or even the lookup. Like if you have like multiple lookups, and then let's say there's like a, I don't know, you resolve a post by blog, but then you have also, you can resolve like a post by, you know, other entity. There's a potential for like conflicts, or, you know, things that we might not check.
it's typical that you have organization repository, right? It's what actually is an actual example of GitHub. And the idea why we want this in the spec, or why I think it should be in the spec, is for the Federation everywhere story, where you can integrate natural graphs into the composition. If we cannot figure it out, we could also postpone it. But at the moment, it's like it doesn't feel right. And
I mean,
I share what your sentiment.
there is one thing that we really have to consider, and I know it's a really, really big topic, and it's a very hot topic. But if we don't do the double bookkeeping, problems are solved.
I'm not sure I understand.
You mean the key, right?
If we just for a thought experiment say there is no keys, the only way to access is through lookups, then you have these problems solved, because the path of a lookup essentially tells you how you can look up things. And with Apollo Federation, you require the keys to know what you have to put into the entity resolver. And the more I think about this problem, the more I ask, is this really something that belongs into the composite schema specification? Because the lookup semantics are completely different from how Federation works. You know, you do not, in Federation, you need the keys. Otherwise, you cannot use the entity resolvers. You require them. You have to have them. In the composite schema, you have the lookups and you have a path of lookups. And therefore, you do not require to have the keys. It's just there for the double bookkeeping. Kamil?
Again, like what I like about keys and double bookkeeping is that, like, if you want to see, oh, how do I get like if you want to check the, the possible queries and like, can I get from A to B, subgraph, whatever, you have like a very simple way to look it up. Like you just go to, just check the type, and there's the contract, which is the key, right? And then you see, so if it's there, it means that if I have those fields, we're good, right? I can get into the blog, the post, the entity itself, right? If it's not there, I need to go to the query, check the lookups, right? Then I need to, and we have the syntax for like is, the mapping and all of that. It just becomes a little bit of not a problem from like a composition or gateway perspective, but more from the user perspective, in my opinion. It's not needed, I would say, but like, I don't know, I like it in Federation, for example.
The argument there is that we're just used to look at the keys in Federation to see how we can look up things. But in the composite schema specification, we always go through GraphQL. So, I mean, you also use the entities resolver, obviously, in Federation. But the composite schema specification doesn't have the entities resolver. So the way to look at what's resolvable is the query type. It's like the entry point into your GraphQL server. And there you have all the lookups. So if you want to know if post by ID has a lookup, you go to the query type and you see that it actually has two, one for by ID and one for slug. It's just another place that you look, but the information is the same, essentially. Martin?
Yeah, I mean, I would say the semantics of key are more general than just being able to look up an object. So what key specifies is that you can uniquely identify an object by a number of fields. And looking up an object is one use case, but caching, for instance, is another one. Or having a sort of a general way of constructing references to objects. I think if we were to tie identity to a lookup path, that would really complicate the notion of identity and preclude us from using keys for other types of optimizations.
Yeah, the question is then, do we specify the key? Do we have to have the tie coupling because from identity to lookup, or are these two separate things?
Well, there is no tight coupling. I mean, lookup semantics don't mention key.
Yeah, they don't.
So they're two different notions that just happen to fit together. And that's what the double bookkeeping gives us. It sort of guarantees that they fit together.
Maybe I need to change wording here, but the question is, do they really fit together?
It's
I mean, even looking at the block case here, right? The nested case, that has nothing to do with lookup. Like the fact that a post ID is like the fact that in order to uniquely identify a post, we need to know which blog it belongs to, doesn't have anything to do with lookup. If that's the case, like for caching, for instance, we would also need a unique identifier that combined the local post ID with a blog ID.
I mean, let's change the example to something which makes more sense, because post by ID is probably here anyway, because it could be that it's just unique ID. But let's say that on block, you can actually have name, and then you have the name. So then the key on post could still be just ID because it's uniquely identifiable by key. But there is an alternative key where you can say in block, each post has a unique name. That could be.
Is maybe also like reiterating on key, is maybe the syntax wrong that we use to specify keys?
In what sense?
That you're forced, basically a key at the moment is kind of downwards. You know what I mean? It's like from my type downward. Whereas when you look at the lookup lookup pass, it's kind of upwards logically.
Yeah, but I mean, I think the problem is that there are different paths to getting to the same type. So upward is relative, and
Yeah.
downwards is always like.
I know it's more controllable. I'm just saying, thinking like what about the issue that we have with key at the moment.
Yeah, I'm not sure I see the issue. I mean, I agree that it's inconvenient. Like if you have a relative an ID that's relative to something that you have to like include
Yeah,
the
you
field
also have
explicitly,
to.
but that's just part of defining the identity.
Yeah.
Like if a user ID, for instance, is relative to an organization, like if a user ID is only unique within an organization, you want that organization ID in your like accessible from your user. That's because otherwise you have no way of constructing a unique identity for that object.
Yeah.
Yeah, it depends. If you for instance see the object the document the document database case, right? You have a graph, and post, for instance, doesn't have really just has name, and it's basically in the same object. But by having these nested lookups, you kind of give it a unique resolve path, basically a function to uniquely resolve this thing. Then you don't really have an identity for post that lives on itself, right? It just is valid within
Yeah.
block.
But why even make it an entity in that case? It doesn't have to be an entity.
Yeah,
Like if it really has no identity of itself, then it shouldn't be an entity.
I think the question is more about does a lookup always need to be combined with the key? Because
No, it doesn't.
Yeah, but that's the thing. If we think about what people have done to keys in Federation, these huge keys just to ship data from one subgraph to the other subgraph.
Yeah.
It's a massive anti-pattern, but they did it because that's the only way that they could do it. And
But we have other mechanisms now, including require,
yeah,
to deal
Yeah.
with that same use case.
yes.
yes.
But
I
at the moment, the specification basically enforces that each lookup has to have a matching key.
Oh, I thought we decided not to.
yes, no,
enforce that.
that's basically what we want to what the discussion goes a bit towards. Like, what's the function of the key if it's not needed for the lookup? Because like if they are not bound, right, kind of, then you could also make all the components that you need shareable, and it would also work.
Well, it would work for the lookup case. But what key gives you is a notion of unique identity.
Yes. Okay, but in the spec, what function would it serve?
Well, I mean, the unique identity for an entity is important from a spec perspective, not just for lookup, because there are other uses for it, like caching. But also, I do think the double bookkeeping is really important here, and documentation.
But this then ties it again
To
with
lookup.
the lookup.
Well, not just the double bookkeeping does, but documentation I think is a more general, as Camille was saying, like just being able to look at a type and see how instances of that type are uniquely identified. That is important from a domain perspective as well.
Yeah. So, I mean, from a perspective, from a lookup perspective, if we look at this problem through lookup, then the tight coupling between keys and a lookup comes from the double bookkeeping. if key serves for unique identity and whatever, that's like something we can call a different topic, right? It's just if you just define a lookup, it's very easy for you to just define a new query entry point, and then you can look up by something.
Yeah.
And that's something which is very, very powerful because we don't need to specify a key for this.
Oh, but I agree with that. We don't need a
Okay.
type. There is no coupling between lookup and key.
Yeah,
Like
because we start where this discussion comes also a bit from is we started implementing that, and just like what we can do basically is just drop the keys and the whole mechanic works then.
Yeah.
If we have a use case for key, then we should make then I agree we should disconnect that from lookup. Because for the lookup case, we can still do these things, like, and then specify in the specification more what the use case of key is. For instance, for caching or whatever.
Yeah, but it's not just for caching. I mean, but the double bookkeeping works the other way around. So you can have a lookup without a key, but there has to be a way of there has to be a path to an entity, and like that's defined by key, like that, because key tells you sort of if two subgraphs define the same key, that tells you that you should be able to
Same
jump
data.
from one to the other.
Yes, but technically, if a lookup says, okay, I can resolve you this, if you have this field and two subgraphs make it shareable, they also kind of say this is semantically equivalent, so it's the same. And if that is what the lookup can work by, then this is also a valid pattern to do that.
It greatly complicates satisfiability and query planning, I would say, because you need to sort of like implicitly derive those
Paths.
those paths. And also, I think a key field is stronger than just a field being shareable because it's also meant to be immutable.
Why? Wait, that now makes things different, because if a key is meant to be immutable, then a lot of the stuff that a lot of the crazy keys that we have seen is actually a wrong use case of the keys. It's not.
Oh yeah, but
It's not
it
even a
is.
stretch. It's not even
Yeah.
a stretch of how you can use keys to do data sharing. It's actually completely wrong to do this because the key is meant to be immutable.
It
And
is, or at least the time frame in which changes occur. Like there shouldn't be short-term changes to it, because you're really changing the identity of an entity is something that you like. It might occur in some weird scenarios or some uncommon scenarios, but it would completely mess up caching, for instance.
Okay.
Yeah, but like
if something is very volatile, it should
identity.
never be part of a key.
Yeah. Okay, so I think we have to rethink this definition again. But then the general notion of you can have a lookup without a matching key is fine. Okay, because that's from
Yes, it makes
exactly at this point now where we start with satisfiability, and as we were talking about the lookups, it's exactly where we end up with, you know.
It actually makes it makes no sense in the case that you look at post and define the key downward, because if you look from a caching perspective, for instance, you would say, okay, I need this and then the block ID, and that's my unique key to identify block.
Yeah.
You don't look from the lookup pass. It's just the pass you can resolve it by.
But that's very good, because then we can
I will update that.
we can change the understanding of it, because then these are two separate things. They can overlap, but they don't have to overlap. And now this makes it very easy for us to say that I just want to, if you have a slug there, you can have a resolver here that resolves it by slug, but you don't have to have a key for this.
Yeah.
But you don't have to.
Yeah, that's. I also will add the semantics that the key shall be immutable. No, must be immutable.
Yeah, or at
How
least must
strong
not.
how strong do we want to define
yeah,
that?
must not be volatile.
Must
We
be immutable most of the times.
yeah, like we
Yeah.
think about it, how strong we want to have that in the spec text. But I think this is also an important information for the user. We should name it immutable.
By immutable, do you mean that like in the schema it can't change and evolve, or do you mean more strongly like the value returned from the server
Yeah, I mean,
for that same object?
I meant the value, but I think immutable, like indefinitely, might be too strong here.
yeah, but if it changes,
but-
it's basically a different. The object has a different identity,
exactly. Yeah.
and
Which makes sense with the caching example that you have brought up. There it makes 100% sense, right? Where you say that if I want to cache by the block ID and the post, and this should be a cache result. If the block if the post is assigned to a new block, it's a new cache key.
Yeah.
But this doesn't change anything in how the lookups work, because the lookups are basically just paths from the query root to the entity. And you can look them up by whatever you have there.
yeah, but it gives yeah. I would scrap. I would update the directive spec text, and we can have a look at that. But we should like should be immutable. Like we meant it to be immutable.
Yeah, I mean this came up recently, and I mean I think it does depend on your application, like how like how important is the caching, how durable does it need to be, because there are some some use cases where it can be handy to change the encoding of the key or something on the back end, and I think that's part of the idea of like the the ID scaler is that it's opaque to the client, and so there are costs associated with changing the ID.
Yeah.
But does that mean you can't ever do it?
No, but from the usage standpoint is if you suddenly get this new encoded ID, it's a new entry in your cache.
Yeah.
And the old key is basically for the consumer, the other key is basically two different objects.
Mm-hmm.
You changed it, now it's two different. Probably the cache will get rid of the old one because now we are using the new one.
Yeah, like eventually, depending on the LRU policy or whatever,
yeah,
eventually it should get rid of the old one. Like it's gonna, depending on the app, this could, cause issues, but but sometimes it's okay.
Yeah, like let's reflect on that. But I think it's a good direction. We talked about that in the beginning. I know that we said they don't belong together, but we kind of still validate. Does this key match with lookups? Like, or there must be a key for the lookup. But actually, you could choose to design it also with shareables.
I think it's the other way around.
How do you mean?
Well, if you define a key on a type, you want to be able to. There has to be a path to that key, so to speak. If you want to be able to look up by key.
Right. But that would again restrict use case, right? Because it could very well be that the path to fetch something, the fetcher, we talked about the naming of lookup, and one was the fetch. And the fetch could theoretically happen completely differently. You wouldn't even have to expose a lookup by a certain an entity by a certain key. It could be that you get this entity through another entity. Like, let's say block and post live on the same service, and you can always only get the block through the post. Then you could still cache the block based on its ID because it's unique and it's unique. But then there does not necessarily need to be a way to fetch by ID because the semantics are a bit different, One is the type identity or the identity in the domain, and the other one is how do you get this thing? And if the only use case that you have in your GraphQL server is to always only fetch the post which is associated with the block, then you can specify that the post actually has an ID, and this is the key of this post, but you don't necessarily need to fetch it.
Well, that would only work within one service, right?
Yeah, but
And-
caching would happen on the edge, right?
Well, I mean, I was thinking of client caching, for instance.
Oh
So
yeah, or on the
it's a
client.
domain notion, yeah.
Or on the client, but let's say you have a
Yeah, but it's a good way. Like there is the disparity, right? What you do with the key, and what you do with the lookup.
Yeah.
Yeah. At the moment,
Let's continue this conversation
Yeah,
next
it's
week.
Yeah. It's a good conversation because that while we are implementing it now, we're seeing these problems, and I'm sure the more we talk about it, we actually find out how the definition of the directive should be written.
Yeah, the way I specified it at the moment, but is that we have also in the lookup examples, always the key, and the key matches the lookup. But that would be not necessarily be mandated. It could be a good practice to do that, depending on what you're building, but it's like not mandated.
There is also schema governance wise, there are many other practices which also could be good. For example, to say that this actually means that another graph can look it up, but I don't think that the directives we have at the moment have very unique use cases, and I think this is very, very good because it makes it very flexible. We just need to figure out what we need. Okay.
We are way over time.
Yeah. Sorry for this.
But let's put it for next week again on the agenda because there are a couple of other things we need to clarify before we change something. Awesome.
All right. Well,
Thanks a
see you
lot.
next week.
Guys.
Good discussions. Bye bye. See you.
It was